In the heart of the modern industrial landscape, a new phenomenon rises: the dark factory. Inside, the air is still. The deafening roar of the past has been replaced by a calculated silence.
They operate with a precision no human hand could ever match, executing tasks measured in microns, tirelessly, endlessly.
This is not science fiction. This is the manufacturing reality of today. Welcome to the era of the AI factory.
But how are these intelligent systems rewriting the rules of the global economy? And what happens when the factory itself begins to think?
For centuries, progress was driven by sweat and muscle. The roar of the furnace and the toil of the worker defined our industrial might.
But the next industrial revolution isn't about physical strength. It is about the mind. Advanced robotics, predictive analytics, self-correcting systems. These are the pillars of a new age. To understand where we are going, we must first look back at the sparks that started it all.
The first industrial revolution gave us the steam engine. We mechanized labor, turning heat into motion.
Then came mass production. The assembly line standardized the world, breaking complex tasks into simple, repetitive motions.
By the mid-20th century, the first robotic arms emerged. They were strong, yes, but they were blind and rigid.
This was blind automation. These machines simply repeated coordinates. If a part moved just an inch to the left, the robot would grasp at thin air.
The game changed with the arrival of the silicon chip. Suddenly, machines could process instructions, and the internet connected them to the world.
Sensors began to flood the factory floor with data. Temperature, vibration, speed, every metric became a...
But data alone wasn't enough. We needed intelligence. The moment automation met artificial intelligence, the factory woke up.
There is a critical difference. Automation does what it is told. Autonomy decides what to do.
The core of the AI factory is adaptability. A single machine can now switch tasks instantly, moving from... And perhaps most importantly, these systems learn. They self-optimize, finding efficiencies that no human manager could ever spot.
This is the industrial Internet of Things, a nervous system where every bolt, belt, and bearing speaks to the cloud in real time.
At the center lies the brain, a processing unit ingesting terabytes of sensory data to make decisions faster than any human operator. The pace of this evolution is exponential. What once took a century now happens in a decade. We are riding a vertical curve.
The stakes are nothing less than the global economy itself. Efficiency, cost, and the sheer possibility of what we can build.
But to understand the mind, we must look at the bod. The machines themselves are waking up.
We have entered the era of sentient machines. Robots that do not just move, but feel, see, and learn.
Haptic feedback gives them a sense of touch so refined, they can handle the most delicate organic matter without leaving a bruise.
Yet that same sensitivity is paired with hydraulic strength, capable of manipulating tons of steel with effortless grace.
In the digital realm, reinforcement learning runs millions of failures in seconds, distilling years of practice into a moment of perfection. The assembly line itself is alive. It breathes, slowing down for complexity and speeding up for simplicity.
Chaos is no longer an obstacle. AI handles variance, picking order out of a jumbled bin with spatial reasoning that rivals our own.
Swarm intelligence coordinates fleets of autonomous vehicles. They move in a collision-free ballet, driven by a collective algorithmic mind. The rigid linear assembly line is dead. In its place, modular islands and dynamic routing allow for infinite flexibility. This enables mass customization at the speed of mass production. Every unit on the line can be unique without slowing the pulse of the factory.
Retooling used to take weeks. Now, adaptability is instant. A product changeover happens in the blink of an electronic eye.
It gives every technician X-ray vision, overlaying complex schematics onto the physical world in real time.
Free from human bias, generative algorithms dream up organic, bone-like geometries that maximize strength and minimize weight.
Computer vision systems scrutinize surfaces with microscopic precision, spotting flaws invisible to the naked eye.
The ultimate objective is the industrial holy grail, a production line with absolute zero waste.
These machines possess a form of self-preservation, sensing wear in their own joints and requesting service before they break.
Biological reflexes simply cannot compete. AI-driven Delta robots sort with a speed that blurs into a hum of motion. This is the factory that never sleeps. While the world rests, the algorithms continue their relentless rhythm. But the body is nothing without the brain. To understand the true power, we must follow the data upstream.
Enter the algorithmic oracle, a centralized intelligence that doesn't just manage production, but predicts the future.
It begins with the digital twin, a perfect virtual mirror of the physical facility, updated in real time. Within this simulation, we can fast forward time, testing millions of disaster scenarios without risking a single bolt.
It detects the heat signature of a failing bearing days before a human would hear the grind. It doesn't just flag the problem, it autonomously orders the replacement part from the supply chain.
The cost of unplanned downtime, once a manufacturer's greatest liability, begins to plummet towards zero.
If a chemical mixture drifts by a fraction of a pH, the AI corrects the formula instantly, saving the batch.
It manages the flow of raw materials like a traffic controller, ensuring no machine waits and no pileup occurs.
It even negotiates with the power grid, throttling non-essential systems when energy prices peak.
But efficiency is also the ultimate driver of sustainability. By optimizing every watt of power,
In the pharmaceutical sector, this precision is a matter of life and death. AI monitoring ensures dosage.
We are witnessing the death of batch testing, where samples were checked after the fact. In its place,
Even in the chaotic world of organic produce, computer vision brings order, grading every single item at speeds no human workforce could match.
To achieve this speed, data cannot always travel to the cloud. It must be processed on the edge, right inside the machine itself.
Because when heavy machinery moves at these velocities, milliseconds of latency are the difference between production and collision.
Yet, connectivity brings risk. As factories go online, they become targets.
We have a spike on the central grid. Rerouting power now.
These systems are not isolated. A machine in Germany can instantly share its learnings with a twin facility in Japan. If a robot encounters an error in one location, the solution is uploaded to the cloud, patching the entire global fleet in seconds. Shared intelligence. The AI even looks outside the factory walls. It watches the weather, traffic, and markets, adjusting production. This predictive power perfects just-in-time inventory. Warehouses are no longer stagnant storage lockers, but flowing rivers of goods. In this ecosystem, the algorithm becomes the foreman. It assigns tasks to humans and robots alike. For human managers, the challenge is psychological. It requires learning to trust a decision made by a logic they cannot see. But as we zoom out from the factory floor, we see that this intelligence is reshaping something far larger, the global economy itself.
We have all seen the fragility of traditional supply chains. One stuck ship, one closed port, and the world grinds to a halt.
The AI factory offers resilience. It can pivot from manufacturing vacuum cleaners to ventilators in a matter of hours, not months. It enables hyper-localization. Instead of one mega factory halfway across the world,
We see smaller, smarter micro-factories embedded directly in the cities they serve.
this is the era of bespoke production. Goods are made only when they are ordered, eliminating the waste of unsold inventory.
The result is a drastic reduction in shipping. The long, polluting voyages across oceans are... The logic of offshoring is inverting. We are witnessing the great reshoring, bringing manufacturing prowess back to home soil.
The old equation relied on cheap labor. The new paradigm weighs efficiency, and the scale is tipping irrevocably toward AI.
Supply chains are no longer rigid chains, but living networks. When geopolitics shift, the system reroutes.
We are birthing entire industries that were once physically impossible, from bioprinting living tissue to constructing microarchitectures.
Why build on Earth at all? Orbit offers zero gravity and infinite vacuum. The next industrial frontier is floating above our heads. The linear take-make-waste model is dead. AI drives the circular economy, meticulously disassembling the old to harvest the raw materials for the new.
Efficiency is the enemy of waste. We are approaching the asymptotic limit of the zero-waste factory, where every atom is accounted for.
We are trading the economies of scale for the economies of flexibility. The monolith is replaced by the modular.
For developing nations, the latter is changing. The advantage of low wages is eroding, forcing a leapfrog into high-tech adoption.
The factory is no longer an island. It is a node in the smart city. Talking about truck system.
Logistics leaves the hands of the driver. Autonomous fleets and heavy-lift drones synchronize with production to the millisecond.
This is the new space race. Nations are competing not for territory, but for algorithmic dominance in the physical world.
But this power isn't just for giants. Robotics is democratizing, putting the power of a factory into the hands of a garage startup.
AI is even inventing the stuff we build with, exploring molecular combinations to discover lighter, stronger materials that humans missed.
These cathedrals of industry are becoming energy independent, generating, storing, and managing their own power with ruthless efficiency.
The sun never sets on the AI supply chain. Production follows the daylight.
But in this chrome-plated future, where does humanity stand? The fear is palpable.
History calls this the Luddite phallus. We feared the loom, the steam engine, and the computer. Yet, we are still here.
If we adjust the parameters here, the conveyor speed increases.
Right, let's test that against the schematic tolerances.
Entirely new professions are emerging from the silicon dust. Robot wranglers, digital twin architects, AI ethicists. We are handing over the dangerous, the dirty, and the dull, keeping our lungs clean while the machines brave the hazards.
But with this power comes a heavy burden. We face new ethical frontiers that code alone cannot solve. The black box problem. When the machine decides, can we understand why? Transparency becomes the new gold standard.
We need guardrails, laws and protocols that ensure the silicon servant never becomes the master.
Looking toward 2050, the factory dissolves into the environment. Silent, clean, and endlessly productive.
From the first steam engine to the neural network. From blind automation to sentient manufacturing.
Welcome to the age of the AI factory. Subscribe for more insights into the machinery of tomorrow.